table B, we want to find the p-value. Is this a one-sided or two-sided? Okay, good. One-sided because mu is greater than 10. The sample size is 75. So we're going to use degrees of freedom equal to 74, right? So here's problem though. Go to table B. In table B, there is no 74 in the table. So what do we use instead? You have to go smaller. You don't want to make assumptions. Having a larger sample size is better, right? So we always want to be on the conservative side and pretend like we have a smaller sample size. So you go lower. Okay, that's what I wanted to point out. So so you're going to use degrees of freedom equal to 60. Always go smaller. Always go smaller to be more conservative. And then, so we're going to go to line 60 and we're going to look for 2.33. So we go to line 60 and look for 2.33, and you see that it is between 0.02 and 0.01. So it is between 0.02 and 0.01. So you would just say p-value, because that's all it wants, between 0.01 and 0.02. So it has between a 1 and 2% chance of occurring. Part B is a two-sided test, right? Okay, so sample size 10, use degrees of freedom equal to 9. That actually is on the table. So we go degrees of freedom of 9, and we're looking for 0.51. But see how 0.51 is not even on there at all? So that means the area is more than there's more than a 25% chance of it happening. There's no way we're going to reject the null hypothesis. In fact, it's a two-sided test, so we have to double it. So the area is actually greater than 50% here. Okay, so for that, there's no t-value small enough. So we know there's no t-value small enough. So area is at least 0.25 and doubled for two-sided test. Don't forget to do that. So p-value is greater than equal to 0.50, at least 0.50, and that we don't need to say any more than that. That's a huge probability. We would never reject the null hypothesis.